Yes, good evening from wherever you're joining us. In our today's class, we're going to continue from where we stopped. That was the three equations of motions we derived from our previous video, and today we're going to continue exactly from there. So fundamentally, what you need to know is the first equation of motion is given by the v is equals to u plus at, and the second equation of motion is given by v square is equals to u square plus 2as, and the third equation of motion is also given by s is equals to ut plus half at square. And it's important to know what each of the parameters there means, what they stands for. The v stands for the final velocity, the u stands for the initial velocity, the a stands for the acceleration, the t stands for the time, and the s here stands for the distance covered. So we will, in today's lesson, we will be looking to solving three problems that I drafted. So we're first going to look at the question number one. Question number one, it says a body initially traveling at a velocity. So the initial velocity u is equal to what? 5 meters per second, traveling at a velocity, traveling at 5 meters per second. It's given an acceleration of 2 meters per second square for 4 seconds. So acceleration is equal to what? 2 meters per second square at a time of what? 4 seconds. Find its final velocity. So we have to find the final velocity. So we can use the first equation of motion, which says the v is equals to u plus at. So since we are asked to find the final velocity, that is the v, we can just substitute directly. Our u is 5, our a is 2, and our time is 4. So 2 times 4 will give us 8 plus 5. Therefore, our final answer for the velocity is going to be 13 meters per second. Okay. So this leads us to the second question, question number 2. It says a body starts from rest, and after 8 seconds, it traveled 100 meters. Find its acceleration. So something you should always put at the back of your mind. Whenever a question reads, an object starts from rest, it signifies that the initial velocity is 0. So you can just see v is equal to 0. And after 8 seconds, so which means time is equal to 8 seconds. So it traveled 100 meters. So it traveled a distance of 100 meters. Find acceleration. So acceleration is what we have to find. So looking at the three equations, which of the equations will suit this data provided? The distance is given, the time is given, the u is given. So you asked to find the a. So you realize that the third equation could work for this one quite well. The second equation cannot work for the fact that there is v and then there is no v given in this particular question. Question number one is totally out because there is no distance in it. So equation 3 would be the most suitable for this problem. So we use the third equation, which says s is equals to ut plus half at square. Sorry. So since we're interested to find a, we just substitute directly, or we can make a the subject. But to make life easier, we can just substitute directly. So we can just substitute s as 100. You substitute u as 0 multiplied by time is just going to be 0. So 0 multiplied by t is just going to be 0 plus half a t. And what is our t? T is 8. So 8 square. So we're going to have 100 is equals to what? So this is going to be 0. It's going to be half multiplied by 64a. Okay, so half of 64, that will give us 32. So it's going to be now 100 equals to 32a. So now we're going to divide both sides by 32 to get a standing alone. Divided by 32. So a now is going to be equals to, so 100 divided by 32, that's going to be 3.12 meters per second square. So that's your final answer for question number 2. So we can look at question number 3. Question number 3. Question number 3 reads, a vehicle is moving at 5 meters per second. So initial velocity, 5 meters per second. How long will it take to stop at a distance of 15 meters? So how long is asking for the time. Will it take to stop? But another very important point to note, whenever a question reads stop, n, which means the final velocity is going to be 0, because whenever the object stops moving, which means it is not having any acceleration, and which means this velocity also is 0, which will lead us to what? The determination of acceleration, or what is going to be acceleration in this case. Acceleration is going to be negative because it's going to stop. Since the vehicle is going to stop, therefore acceleration must be retardation, negative of acceleration. So we are expecting a negative acceleration, okay? So acceleration must be negative in this case. And the distance is given by 15 meters. Okay. So we asked to find the acceleration. We asked to find the, we have to find the time, not acceleration. Okay, but we cannot find the time without getting the acceleration. We must first get the acceleration, and that we have to use the second equation of motion. It says v square equals to u square plus 2as. Now potentially our a must be negative, so we have to substitute a negative a because it's retarding. So the v is 0, so 0 square is 0. The u is 5 square plus 2 into negative a. So you have to use minus a because we are dealing with retardation in this case, negative of acceleration. And the distance s, okay, distance of 15 meters. So it's 15 meters. Going to be now 0 is equal to 25 plus, so 2 times 15, that's 30. So this minus will, plus will go, plus minus is going to be minus 30a. So if you transpose this to this side of the equation, you're going to have 30a is equals to what? 25. So the minus 30 will come to this side. You have both side by 30. You have both side by 30. And if you point this in the calculator, you're going to have something like 0.833. So 0.833 meters per second square. And that is our acceleration. But this is not our final answer. We have to find the time. How do we get the time? Go back to our first equation of motion. That is the v is equals to u plus at. All right. Now we are given our v as 0, our u as 5, plus our acceleration. Since it's negative, acceleration is negative, we're going to have minus, okay, minus 0.833, okay, minus 0.833 multiplied by the time. What is the time? Is what we are finding, right? So we are finding the time. So we're going to have this going to the other side of the equation. 0 minus 5 is equal to minus 0.833 t. So divide both sides by minus 0.833. Divide both sides by 0.833. This will go away, so our time is going to be minus 5 divided by minus 0.833. So the negatives will cancel, and our final answer is going to be 6 seconds. 6 seconds. That's the end. That's the final answer for the question number 3. And that will be the end of our video for today. If you find this video helpful, please don't hesitate to like, comment, share, and hit the subscribe button. And also, please, you can forward this video to your friends and colleagues and loved ones. Thank you for joining.